what in the world is addition and subtraction of fractions? And it's addition and subtraction of anything. Addition and subtraction is a counting process. But in order to count anything, you have to count things that are alike. And you can't combine things unless they are alike. In other words, they have the same name. I could look at a classroom and say, I have so many girls and I have so many boys, but I can't combine you unless I say, I've got students. Because now the boys are students and the girls are students, and then I'm counting students, not two things that are distinctly different. And that's what addition and subtraction does. It counts, but it can only count things that are alike. And when I think about fractions, it's the same thing. I've got to be looking at pieces. And in this particular instance, there are pizza pans, and that's what these guys are, that are divided into 6. So if I take a look at what's happening here, this is divided into 6 pieces. And you notice that this says, out of 6 pieces, I have 2. So that's what you say, this is 2/6 of a pizza. And here I have the same thing, and they are also in 6ths. And I have 1 piece, so this says, of 6, I have 1/6 of a pizza. So that says, how much of a pizza do I have? Well, since they're all in 6, they're the same size, I would say, here's 6. Here is the 2/6. Here is the 1/6. So here's 2 pieces, here's 1 pieces. How many pieces do I have? I have 3 pieces. It's in 6, so it's 3/6 of a pizza. And then because this is a fraction, namely 3/6, we would reduce it down to 1/2, and you can see this is nicely 1/2 of a pizza pan. So you've got to count them. They've got to be identical, otherwise you cannot. And our focus, at least for this piece of 7-3, is counting things that are identical. So if I now go to the abstract, which is the arithmetic problem, which says if I had 1/4 and I'm adding 2/4, what do I have? It says I have the same denominator, the same name, which is fourths. How many fourths do I have? 1 plus 2, or 3/4. But the name has to be the same. Doesn't matter what the name is. Those things have to be identical. Then it says, how many do I have? Then I count the numerator. The numerator says how many. So this guy is how many. And the denominator says what? How many whats? So the denominator is what I'm counting. The numerator is how many of that thing I have. And if they're the same, then I can bring them together and count them consecutively. Now subtraction works the same way. Again, what am I counting? I'm counting fifths. So you notice these two are the same, so that's going to be the same, so I can count them. How many do I have? I have 4 of them. I'm taking away 2 of them. How many of them do I have? I have 2 of them left. So if I have 4, somebody takes away 2. How many do I have left? I have 2. But notice, these denominators have to be identical. Otherwise, I can't count them. That's true in arithmetic. That is absolutely perfectly true in algebra. Same thing. So if I now look at the algebra aspect of this, that says, what would it say? It says, well, the same thing. If I'm adding, I have to make sure what I'm counting is the same. So these two are the same. I'm counting how many beasts I have. I have A of them, I bring in an additional c of them, it's a plus c of them. So if the denominators are the same, I add the numerators, because the denominators tells you what, and the numerator tells you how many. So I can just bring them together and count how many total I have. Same thing if I have subtraction. If I'm dealing with subtraction, this again, these are the same. And it says, of them, because these are the same, how many do I have? I have a minus c of them. So I said I have so many, and somebody's taken away so many. How many do I have left? Of them. But I have to be counting the same thing. Now, the algebra example is now this. We start with something simple, and it says, suppose I have 2x minus 1 over 3 added to x plus 4 over 3. I notice the denominator is the same. So I've got x minus 1/3 and x plus 4/3. The question is, how many thirds do I have? Because this thing is the same. Well, in the thirds world, I would have 2x minus 1 added to x plus 4. I add the two numerators. Numerator 1, numerator 2, add them together. I can count the total. This says I have 3x plus 3 of them, 3x plus 3 over 3. We notice that we've got a greatest common factor of 3. So at this point, I combine like terms, and then I factor and simplify. Or essentially what we did on the top, we reduce the fraction. So that takes us back to essentially what we did in 7.1. We simplify, which is reduce the fraction. And then my final answer then is just x plus 1. See, and this is analogous to taking 3/6 and reducing it down to 1/2. Only now we're in the algebra world instead of the arithmetic world. They should match. The processes match. It's just that they're a lot more complicated.